morning children. Today we are going to learn about the new theorem that is called the Pythagoras theorem. So before we go to learn about the Pythagoras theorem, I wanted to explain some few important points or few elements of the right angle triangle. So right angle triangle means already the name itself says right angle. Right angle means you know that the angle is equal to 90 degree. So the angle is equal to 90 degree. So here if I take this is one of the triangle, then here it is the angle that is equal to 90 degree. The angle is equal to 90 degree. So the side opposite to this right angle, we call it as a hypotenuse. What we call this? Hypotenuse. Okay. So this one is called the hypotenuse. So the angle is 90 degrees here. We can see that by seeing the picture. 90 degrees. So the side opposite to this side we call it as a hypotenuse. Okay. So let us take some different rotated triangles. So here I have taken here one more right angle. Can you tell me here where is the right angle? So here it is the right angle. So it is the 90 degree. Then which side is the hypotenuse? Opposite to this 90 degree. That is this one is the hypotenuse. Okay. Next one. Let me take this one triangle now. So if I take this triangle here it is the 90 degree. By seeing the picture only we can say that. We can tell that which is the right angle. So this is the 90. Then hypotenuse is, this is the hypotenuse. Okay. So let me give the names for these triangles. So if I give this is the angle A, sorry side A, vertex A, B, C. Okay. So these are the points I am giving here. Okay. Otherwise we can give like this A, B and the C. Okay. So like this I can give the names. Here now what I will do now, here this is opposite to this. So here this side I am taking it as a small letter C. And this one I will take it as a small letter A. And this one this side I am taking it as a B. Okay. So here also in the same pattern in this right angle also I will take it as A, B and then C. So this hypotenuse I will take it as a C. The side opposite to angle A is I am taking it as A. And angle B is opposite side is small letter B. Okay, like this I will take. Now let us come to the Pythagoras theorem. So what is this Pythagoras theorem tells us? This theorem tells that in a right angle triangle, means in this right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So the square of the hypotenuse, so square of the hypotenuse means c square is equal, c square is equal to the sum of the squares of the other two sides. Sum of the squares of the other two sides. Okay. So what it tells that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay. So this is what the Pythagoras theorem tells us. Okay. So this is about the Pythagoras theorem. Means the square of the hypotenuse. Here the important thing is you have to identify exactly the right angle and then identifying the hypotenuse. And the remaining two sides squares and the sum that will be equal to the square of the hypotenuse. So if you are able to identify the hypotenuse, then it will be very easy. So the square of this hypotenuse is equal to the sum of the squares of the other two sides. So this is called the Pythagoras theorem. So this Pythagoras theorem is first invented by, is presented by a Greek mathematician or philosopher called Pythagoras. Okay. So this is first introduced by him. Okay. So now let us come to the next one is called converse of the Pythagoras theorem. Converse of the Pythagoras theorem means reverse. Almost we can say that reverse. Reverse means not completely reverse. Only we will change the sentence little bit. Okay, so that is called the converse of the theorem, converse of the Pythagoras theorem. What it tells? If the square of the one side of a triangle is equal to the sum of the squares of the other two sides, then that triangle is a right angle triangle. That triangle is right angle triangle. Okay, how we have to remember? See children here. Here first we say that in a right angle triangle. Okay, in a right angle triangle, first only we are telling that the triangle is right angle triangle. Afterwards we will say that the square of the hypotenuse is equal to the sum of the squares of the other two sides. But in the converse, first we will say that if the squares of the one side of the triangle is equal to the sum of the squares of the other two sides, then the triangle is a right angle triangle. So that is the converse of the theorem. Okay. So now let us come to the next one. So that is called the corollary. Means these are the results of the Pythagoras theorem. These are the results. Means that we will it came from this Pythagoras theorem. What are those important points? Okay, from the Pythagoras theorem. That is the first one is called the corollary one. What it tells that in a right angle triangle, the hypotenuse is a longest side. The hypotenuse is a longest side. It means what? Here, if you take here, c square is equal to a square plus b square. Okay. So, here we can say that. So, c square is equal to a square plus b square. This is the Pythagoras theorem. Okay. It means that this c square is greater than a square. Correct. In the same way, c square is greater than b square. What it implies then? That is c is greater than a and c is greater than b. Okay, so this is what we can say that. So we can easily say that hypotenuse is the longest side. Okay, so this is the corollary 1 of the Pythagoras theorem. Now let us come to the corollary 2. What is this corollary 2 tells us? So here it tells of all the line segments that can be drawn to a given line from a point not lying on it. For example, I am taking one line here, one straight line. I am taking one extra point that is not lying on that line. Okay. So if I draw any lines from here, okay, like this I am going to draw the lines. Okay, I am drawing the lines like this. Here it is a point, I will take it as a O, and here I can give the name as A, B, C, D, E, F and then G. Okay, I am giving for the other point joining points as A, B, C, D, E, F, G. Okay, like this I am giving their names. Here, of all the line segments that can be drawn, from a point that is not lying on a line, that is lying on it, the perpendicular line segment. The perpendicular is what? OD. So that is the line, is the shortest line. That line segment is the shortest line segment. So that it tells us. So this one, by doing an activity, we can come to know that. Okay. Okay. See children, here this is the one of the straight line and this is the one of the point. Okay. So here I have taken one line segment from this point to on this line like this. If you see here, this is the longest compared to this one. So how? See here, this is the what I have drawn, the perpendicular line here. Okay, let's see now this is shorter or not. So if I draw here, so here you can see that this is the shortest now. If I am taking the line segment here, then let's see here also it is a shorter only, that perpendicular line. If I take here also if you see it is the shortest. Let me take here at least. Okay, then also it is a shortest only perpendicular. Now here in the same way here, if you take the point here, Then also, wait, I will take like this. Here see, this is the perpendicular is the shortest. Now if I take like this, see here. By taking the any point on the line, if you take this perpendicular line, that will be the shortest line segment. Okay, that joining the point and the line segment. The perpendicular line is the shortest line segment. Okay. Okay, see children, here by doing an activity we can come to know that OD is the shortest compared to the OC, or OD is less than the OB, or OD is less than the OA. Or if you take this side, then OD is also shorter than OE. Like this, for all the line segment, if you compare, this is the shortest line segment that joining the O and then this line. Okay, that is in the perpendicular. Perpendicular means here it is a 90 degree. Perpendicular means it is a 90 degree. Okay, so this is about the Pythagoras theorem, converse of the Pythagoras theorem, and corollary 1 and the 2. Okay, thank you.